Welcome back to part 2 of the Python crash course. Let's jump back to the Jupyter Notebook and get started. In part 1, we discussed all the basic data structures that Python has to offer. Now let's discuss some of the basic operators, such as comparison operators and logic operators, as well as discussing for loops and while loops. Let's start with comparison operators. Comparison operators just allow you to compare two different variables or two different numbers, two different strings, etc., and then get back some sort of Boolean value, either true or false. For example, if I want to check if it's 1 greater than 2, well, that returns false. Is 1 less than 5? That returns true. So let's walk through a couple more of these. I can do greater than or equal to. I can do less than or equal to. And then I can check for equality using two equal signs. So is 1 equal to 1? Well, that's true. And I can do the same thing for strings. Is A equal to A? Well, that's true. And note, this is case sensitive. So capital A equal to A, that's going to return false. Those are not exactly the same. And if you want to do inequality, it's just an exclamation point. So is 1 not equal to 2? Well, that returns true. They are not equal to each other. Now let's discuss logic operators. Logic operators just allow you to combine multiple comparison operations. For example, if I want to check is 1 equal to 1, well, that returns true. And if I want to check two conditions, then I just use and. And then in parentheses, I can put in the new condition. So I want to check is 1 equal to 1 and is lowercase a equal to lowercase a. Well, that's true. So for example, let me change just one of these, and that returns false. So I always recommend using parentheses whenever you use logic operators, but you don't actually need them in a lot of cases. So if I just run this, it will run fine. But I always recommend having parentheses. Makes it a little more readable, in my opinion, and it also makes sure that you don't get any errors. Okay, so that's the and comparison, or and logic operator, excuse me, and then there's the or logic operator. So a lot of times in other languages, these are either ampersands or pipe operators. Luckily for us, it's just simple English, or for or, and then and for and. And you can do more than just two. You can kind of stack these on. So we'll say and maybe, I don't know, 3 equals to 3. That returns false again. So let's change one of these to be 1. Run this, and then that's true. So that's really all we need to know about logic and comparison operators. Now let's discuss if, elif, and else statements. So these are essentially just if, else, if, and else statements. This is quite simple in Python. All you have to say is if, and then whatever condition you want to check. So for example, if 1 is equal to 1, colon, and you notice when I hit enter, I get an indentation there. So Python depends a lot on white space. So unlike other languages that will separate these sort of code blocks with curly braces, Python just uses white space and indentation. That's why a lot of times it's recommended for beginners, or a lot of people really like programming in it, because this sort of white space makes things readable and makes things very simplistic. So if 1 is equal to 1, I want to print, I don't know, yeah. And then we get out yeah. So let's say if 1 is equal to 2, print yeah. If I run this cell, I don't get anything back, which makes sense because 1 is not equal to 2. So that's a simple if statement. Now let's show you an if-else statement. So I can say if 1 is equal to 2, print worked. If I want to add an else to this, then all I have to do is line up the else with that if, and else doesn't have any condition because it's kind of a last case thing. And then we'll say nope. And let's make sure that's all in a string. And then shift enter, and I get back nope. So if 1 is equal to 2, well, that never executed. So then we get else, print nope. If you want to check for more conditions, then you just add in an elif. So that's elif right there. And then you can add in a condition. And this condition doesn't need to be in parentheses. So a lot of times in other languages, you would see a parentheses here and then some sort of condition check. In Python, you don't actually need it. Everything just works off that colon. So here I'll say elif 3 is equal to 3, colon. And note when I hit enter, there's automatic indentation there. I will print second condition true. So I run this, and I get second condition true. Great. So that's really the basics of an if, elif, or else statement. So moving along, let's talk about for loops. So for loops in Python are actually quite simple. You can for loop through a lot of different sort of sequences or objects, including lists, dictionaries, and tuples. We'll just focus on lists since that's basically what we're going to be using throughout the course as far as for loops. So we'll say a sequence, 1, 2, 3, and let's add a couple more numbers, 4, 5. So there's seq, it's just a list, and I'm going to say for item in that list, which is sequence, colon, note the indentation, and then we can do something, such as print every item in that sequence. And now that gives me back 1, 2, 3, 4, 5. Now, a common point of confusion for newcomers to Python is, does it have to be this keyword item? Well, actually, no. This can just be any temporary variable name that you want. So let's make it really obvious by calling it jelly. And if I run this, I get back the exact same result. Perfect. So I also don't actually need to use this variable. So for example, I can say for element in sequence, print hi. And then if I run this, I get hi, 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 etc. And then I can also use something like element plus elements, and then I get 2, 4, 6, 8, 10. So basically doubling each element in that sequence. So that's all you have to do for a for loop. It's just for, then whatever temporary element variable name you want there, in, and then whatever sequence you're using for that for loop. Quite simple. Now let's discuss while loops. So while loops keep running while a condition is true. So I will say I is equal to 1, and then while some condition, for example, while I is less than 5, and currently it's set to 1, so that makes sense, I will print I is curly brackets, and then I will say dot format, insert I there. And then I don't want this to run forever, so let's say I is equal to I plus 1. Then I do shift enter, and I get 1, 2, 3, 4. So what's actually happening here? Well, I is equal to 1, and while this condition is true, I less than 5, I'm just going to print out I is currently I, etc. So it goes 1, 2, 3, 4, and on that very last one, it says, okay, well now 4 plus 1 is 5, so I is no longer less than 5, it's actually equal to it, so this loop ends. And that's the basics of a while loop. Let's discuss two more things, a range function and list comprehension. Often, you'll want to quickly create a list of integers. So for example, a lot of operations, it's really common to do something like 1, 2, 3, 4, etc., and then loop through a certain number of items. But you can actually really quickly create a list that looks like this using range. So for Python 3, if I just say range of 5, it just gives me back this sort of range generator. But I can cast it into a list, and it gets me back a list of integers. And I can actually specify the starting point and the end point. So if you're ever confused on what a function actually does, you can just, again, use Shift-Tab, and it will tell you the docstring. So it's quite easy. So range, you can say stop, and it gives you back that range object. Or you could also say the start and stop. And you can even indicate a step size. So let's see that in action. I want to start at 2, and let's go to 5. So something that's kind of confusing for beginners is why is 5 not included here? Well, you can think of it as basically up to but not including 5. So it only goes to 4. So we say the stop is up to but not including that integer, that last integer. And the reason for that is because indexing starts at 0. So you can almost think of it as kind of taking away 1. All right, so that's the basics of range. And you'll commonly see range used in a for loop without this sort of list call. So you can say for x in range 5, and then we'll say something like print hi. And there we see hi, 1, 2, 3, 4, 5. Okay, so this is 0, 1, 2, 3, 4. So 4 is up to, but not including 5 there. And that's the basics of range. And we'll see it every once in a while, not too often throughout this course, but it's common enough that you should know it. Finally, let's discuss list comprehension. So list comprehension is a really useful feature of Python. Often you'll find yourself trying to build out a list. So let me show you an example of that. I'm going to create a list, 1, 2, 3, 4, 5. And then I will say out is equal to an empty list, so just those square brackets. And I'm going to say for num in x, take out and append that number squared. And then outside of this for loop, note my indentation, how it's lining up with that for. So once that for loop is done, I'm going to print that out list. So let's run this. And we get what we expect, 1, 4, 9, 16, 25. So what am I doing here? Well, I have out as my empty list, and I'm saying, okay, for every number in that X, append the squared number of it. And then at the end, print out that entire list. So 1, 4, 9, 16, 25. This sort of action is so common in Python to build out a list this way that they've actually created essentially a shortcut, a way to flatten this out into what's known as a list comprehension. So I'm going to convert this sort of for loop into a list comprehension. And the way we do that is we say, put everything inside these square brackets. And then we start by saying num to the power of 2, or whatever you're trying to append. And then we say for num in, and then the iterable was x. And if I run this, this gives me back the exact same thing that this for loop did. So you can think of it as just another way of writing out a for loop that particularly creates lists. So if you ever find yourself constantly appending to a new list inside of a for loop, you may want to consider list comprehension as a possible solution just to flatten this out. As far as readability is concerned, for newcomers, this is not as readable as a for loop, but once you end up working with Python a lot, you'll end up preferring list comprehension. It's slightly faster. There's a very tiny performance boost there, but for certain situations, it's negligible. Okay, so that's really all we want to discuss for part 2. Coming up next, we'll discuss functions, lambda expressions, and then methods as well. Okay, thanks, and I'll see you at the next lecture.